what's happening, guys? Welcome to your third asynchronous JavaScript tutorial, and in this video we're going to dive right into callback functions. Alright then, so callbacks are pretty abundant in JavaScript and chances are you've probably been using them already in your code, but just to go through the basics again, what I'm going to do is a simple example. So I'll create a variable and I'm going to call this fruits, and this is just going to be set equal to an array of fruits. So we'll say banana, apple maybe, and then pear. Okay, so now what I want to do is use a for each method to cycle through each one of these. So I'll say fruits dot for each, and then right in here what we're going to do is pass this a function, and that there, my friend, is a callback function. So we have an array of fruits which for each cycles through, and as a parameter for this for each method we pass in this callback function, and that callback function can do something with whatever data is passed to it. In this case it's passed the value of whichever array pocket we're up to in the for each cycle. So we'll just put in val and we'll say console.log, if I can spell it, val. Right, so now we should see those values output there to the console: banana, apple and pear. So in a nutshell, a callback is just a function which is provided as a parameter to our other methods such as for each, and it is invoked at a certain point in time. Now this callback is declared in line, which basically means we've written all of the code for this function inside these parentheses right here as a parameter, but they don't have to be like that. What we could do instead is get rid of that. We can declare our function first of all like this and give it a name. We'll say callback, and then right in here we can just say callback like so, and this will do exactly the same thing. So it still logs those out to the console. So this is a synchronous callback, meaning it happens right away before the function returns. And I can demonstrate that by logging something right here to the console. I'll say console.log done, and then press save, and now we get done after all this happens. So this callback function is called synchronously. Okay, it doesn't call it at a later point in time, which would be asynchronous. It calls it straight away, does all that stuff first, and then it moves on down the thread to the next thing, which is this console.log message done. Okay, so this is a synchronous callback. But we want to take a look at asynchronous JavaScript and what happens with callbacks then. And remember, the byline of asynchronous JavaScript is something which can start now and then finish up later. So if we take a look at an asynchronous example, let me just get rid of all this, where we go out and retrieve some data. So I'll say jQuery.get, and this is the method we used in the last tutorial where we go out and grab some data using jQuery's get method. Going to pass in the path to the data I want, which is data / tweets.json.
Hello everybody. Hello everybody. Kyle here from Web Dev Simplified. In today's video, we're going to be talking about promises in JavaScript, which look incredibly difficult, but are much more simple than they actually appear. So let's get started now. To get started, let's talk about the idea of a promise before we get into the actual syntax of it. A promise in JavaScript is just like a promise in real life. What you do is you commit to something by saying, I promise to do something. For example, I promise to make the best video on promises I can. And then that promise either has two results. Either that promise is completed, it is resolved, or that promise is failed and it is rejected. So if I give you the best video ever on promises, then I would resolve my promise to do so. But if I failed to give you the best video ever on promises, then that would be rejected because I was not able to complete that promise and I rejected it. So now let's look at the actual syntax of creating a promise. We can just create a variable here, we'll call it p, and we're going to set it to a new promise. And this promise object is going to take one parameter, which is a function, which gets passed two variables of resolve and reject. So we have our resolve parameter, our reject parameter, and then we need to actually create the definition of that function inside. And if you're confused by this arrow syntax here, just check out my video where I cover the arrow syntax for functions because it's extremely straightforward and much easier to write functions in this manner. So after you're done checking that out, now inside of this promise section, we need to define what the actual promise is. So in my example, the code inside of here would be me giving you the best video ever on promises. So we're just going to put some simple code in here. We're going to create a variable a, and we're just going to set it to 1 + 1. So that way, this is what the promise does. And if this failed, we would reject it. So we would say, if a is equal to 2, we would resolve it, but if it is not, so let's say it's not equal to 2, we would reject. So in the reject, we can pass anything that we want back into this reject. We're just going to pass a message that said failed, and then in our resolve, this again, we can pass it absolutely anything we want, but we'll just pass it a message that says success. So, as you know, this code is always going to be successful because 1 + 1 is always equal to 2, so it's going to recall this resolve method that gets passed in. But if we change this to be 1 + 2, we would get this reject method because it doesn't equal 2 anymore, and we would be calling the reject method. So now let's look at how we actually interact with promises. So if we go down here, we can just say that p, since it's our promise, then all we have to do is say .then. Anything inside of a .then is going to run for a resolve because I say I'm going to give you the best video ever on promises, then you are going to do something else after I'm done with that. So in here, this then all it does is take a method. In our case, it's going to just have a single parameter since we're passing a single parameter to resolve, and that's just going to be our message. And then we just want to define what we do with that function. So we can just say console.log, this is in the then, and then we can just pass it the message so we can actually see what that is saying. But to be able to catch an error, we need to use the .catch version of this. So we just say .catch, and this will catch any errors, which are our reject states. And just like our then, we're just passing it a single parameter of a message. And we can just do something very similar. We would do console.log, this is in catch, the catch, and we can just print out that message, and there we go. This is exactly how you use promises. They're very similar to callbacks, which we're going to look at in a little bit, but a little bit cleaner way of doing callbacks. And as you can see, then is going to be called when our promise resolves successfully, and catch is going to be called if our promise is rejected or fails. So now let's actually run this and see how it looks. So now if we save that, you'll see that we got this is in then, and it is a success because 1 + 1 is equal to 2. And if we change this to be not true, and we save it again, you'll see that this is in the catch, and it has failed. So as you can see, when we call this, we create a promise here, we tell it what we want to do when it succeeds, we tell it what we want to do when it fails, and then in our code we say, do this when it succeeds, and do this when it fails. Promises are really great when you need to do something that's going to take a long time in the background, such as downloading an image from a different server, and you just want to do something after it's complete instead of making everything else wait for it. And then also you can catch it to see if it's failed, so that way you can maybe retry it or give the user an error message if it did fail. So now let's look at an example of how we can take something that uses callbacks, which are what promises are meant to replace, and actually replace it with promises, and it's a lot easier than it sounds. I have open a very simple callback function which takes two callbacks, one for the success and one for an error, and all it does is check two variables to see if either of them are true. If they are, it'll throw an error, and if neither of these variables are true, it'll call the success callback saying that everything went well. So this watch tutorial callback function, all we do is we call it and we give it our two callbacks. Our first callback is going to be for successes, and our second callback is going to be for an error. So if we save this and run it, as you can see, both our variables are false, and we get success, thumbs up and subscribe. But if we change one of these variables to true, let's say the user left while watching the tutorial, and now going to say user left with a frowny face. Or if we change that back to false, and we change this one saying that the user is now watching cat memes to true, it'll say that the user is watching a cat meme and that cats are better than me. So now let's implement this using promises instead of callbacks, because this is what promises were really meant to solve. So all we need to do is we can just copy this entire function here. We'll just paste it down here a little ways so we can have it to work with, and we'll just change it to be promise instead of being callback for the naming. And we can completely remove both of these callback functions or parameters, because that's the whole point of using promises, is that we no longer have these callbacks. And all we need to do inside of here is return a promise. So we can say return new promise, and as we know, that promise takes two parameters, the resolve and reject. And inside of that function, we just want to define all of our code that was calling these callbacks. So resolve is going to be our successful callback, so we can just replace everywhere where we have callback with resolve, and reject is going to be that error callback, so we'll just replace all of those. And there we go, we've completely overhauled this function to use promises instead of callbacks. And as you can see, the code itself is almost exactly the same. All we did is change a few variable names, and now we're returning a new promise instead of calling the callbacks. So now let's look at how we can actually use this function. So let's copy what we have up here so that we can see how we need to change this watch tutorial callback into watch tutorial promise. So the first thing that we know is that this is a function that takes no parameters, so we need to call this function and then do something afterwards since it returns a promise. So we say .then, and then, like we know, is going to be our success callback, so we can make it our very first method here, which is this. So as soon as that function is done, we just need to end that, and now we can do our .catch. So we just add .catch in here to catch all of our errors, and there we go. We've completely transformed that callback to be using promises now, and as you see, again, our code is almost exactly the same. So now, if I comment out all of this callback related stuff, and if we rerun it, you'll see that we get the exact same output for no matter what set of variables we have. Let's say we change it all to false, you see we get success. Change this one to true, and again, you'll see user left, and this is using promises now instead of using callbacks. And as you can see, the code is a lot cleaner to write than with using callbacks, because as you start nesting callbacks, you start to get in a huge cleaner and this is just change this one to true, and again, you'll see user left, and this is using change this one to true, and again, you'll see false. See that we get the exact same output for no matter what set of variables we have. Let's say we change it all to false, you see we get success. Change this one to true, and again, you'll see user left, and this is using promises now instead of using callbacks. And as you can see, the code is a lot cleaner to write than with using callbacks, because as you start nesting callbacks, you start to get in a huge world of trouble where your code just keeps getting indented and indented even further. But with promises, instead of nesting callbacks, all you do is just add another then, so it would look just like this. You would have then and then, instead of having a callback inside of a callback inside of a callback, which is what's known as callback hell, and it's absolutely terrible. Promises are great, and they completely solve that problem for us. Now that we have an understanding of how promises work, let's take a look at some of the things that we can do with promises. I've changed my code a little bit here so that now simple promises being created, and they're super simple. All they do is always resolve, they never reject, and they just send a single message when they resolve, and each one of these is about recording a new video for my channel. So let's say we want to do something after I recorded all 3 of these videos, and we want to run all of these in parallel at the same time so we don't have to worry about waiting for one before we start the next. We can use what's called promise.all. So we just say promise.all, and inside of here, we send in an array of all the different promises that we want to run. So in our case, we want to record video 1, we want to record video 2, and we want to record video 3 as well. And promise.all is going to run every single one of these promises, and as soon as it's done, it is then going to call the .then and .catch methods depending on if they resolved or failed. So in our case, all of these are going to resolve, so we'll use a .then, and this .then is going to send an array of all of the successful messages. So it's going to send us an array with all of these different resolved parameters. So we're going to have a messages in here, and this messages is just going to be an array that we're just going to print to the screen. So we'll print messages, and if we save that, you'll see that we got video 1 recorded, video 2 recorded, and video 3 recorded in this array here, which is exactly perfect. That means all of our promises ran, and they all returned, and as soon as they were all done, it called this .then method. And you can't really see that with this example, but these are all running at the exact same time. So if this one, for example, took a long time and actually needed to call the database, for example, and get some results back, it'll run at the same time as these other two. So if these other two are very quick, they won't have to wait for this first one to finish. And now, let's say that we want to just do something as soon as one of my videos is done being completed. We can use promise.race instead of promise.all. And promise.race is just like promise.all, except for it'll return as soon as the first one is completed instead of waiting for everything to complete. And because of that, it'll only return a single message in the .then as opposed to all of the messages. So now if we run promise.race, you'll notice we're only going to get one return value, which is video 1 recorded. And that's as we expected. Video 1 was the first one to record, and that's just because these are so simple, it's always going to run them in the same order. And that's all there is to creating promises in JavaScript. They're extremely straightforward once you understand the concepts of resolve versus reject, and very similar to callbacks, which you probably already know from using JavaScript before. So if you enjoyed this video, please make sure to subscribe to my channel for more videos like this, and check out my other ES6
Salut. Comment ça va? Il a forme. Tu profites bien de ton week-end. Ouais. On peut dire qu'il y a la forme. J'apprends quelques nouveaux thèmes. Un peu compliqués. Mais bon. Faut juste que je fais un peu quelques pratiques. Ouais, c'est ça. Parce que à skip le thème, si je vais utiliser ça pour je vais utiliser ça pour faire l'application de météo là. Donc c'est plus ça. Les 26 minutes. 22.
Thanks for coming to the sidetrack. It's awesome to see. That's good, I need to stretch. So the event loop, and what the heck is the event loop? As in the event loop inside JavaScript. So first up, as he said, I work for Envie, which is an awesome little dev shop / product company in the US. Look us up if you need help with real-time stuff. That's what we're good at. So about 18 months ago, I'm a paid professional JavaScript developer. I thought to myself, how does JavaScript actually work? And I wasn't entirely sure. I'd heard V8 as a term, Chrome's runtime, didn't really know what that meant, what that did. I'd heard things like single-threaded, obviously I'm using callbacks, how do callbacks work? So I kind of started a journey of reading and research and experimenting in the browser, which basically started like this, right? I kind of was like, JavaScript, what are you? And it's like, I'm a single-threaded non-blocking asynchronous concurrent language. All right, that's, yeah, cool. I have a call stack, event loop, callback queue, and some other APIs and stuff. Right, I did not do a computer science degree. I mean, these words, they're words. So, I heard of V8 and the various runtimes in different browsers, so I looked at V8 and said, do you have a call stack, event loop, callback queue, and some other APIs and stuff? I have a call stack and a heap. I don't know what those other things are. Okay, interesting. So, basically 18 months pass. We're 18 months later now, and I think I get this. And so this is what I want to share with you today. So hopefully this will be useful if you're relatively new to JavaScript, help you understand why JavaScript is so weird when you compare it to other languages you might have used, why callbacks are a thing, which cause us hell but are required. And also if you're an experienced JavaScript developer, hopefully give you some kind of fresh insights into how the runtime that you're using every day works so that you can kind of think about it a little better. So if we look at the JavaScript runtime itself, like V8, for example, which is the runtime inside Chrome, this is a simplified view, really, of what the JavaScript runtime is. It's a heap, which is, we don't need to worry about, that's kind of boring, it's just where memory allocation happens. And then there's the call stack, which is where your stack frames are and all that kind of stuff. But if you clone the V8 codebase and grep for things like set timeout or DOM or XML HTTP request, they're not in there. They don't exist in V8, which is kind of a surprise to me, right? Set timeout's one of those first things you use in JavaScript when you start thinking about async stuff, and it's not in the V8 source. Interesting. So over this 18 months of discovery, I've come to realize that this is really the bigger picture, and this is what I'm hoping to get you all kind of on board with today and understand what these pieces are. So we have the V8 runtime, but then we have these things called web APIs, which are extra things that the browser provides. So the DOM, AJAX, set time, things like that. Then we have this mythical event loop and the callback queue. I'm sure you've heard some of these terms before, but maybe don't quite understand how these pieces pull together. So I'm going to start from the beginning. Some of this will be new to, or the words might be new to people. Other people might get this, but we're going to quickly kind of move on from here. So bear with me if this is obvious, but I think for a lot of people it's not. So JavaScript is a single-threaded programming language, single-threaded runtime, which means it has a single call stack, and it can do one thing at a time. That's what a single thread means. Is the program can run one piece of code at a time. So let's try and visualize that just to get our heads around what that means. So if I have some code like this on your left, we've got a few functions. A function multiply, which multiplies two numbers. Square, which calls multiply with that the same number twice. A function which prints the square of a number by calling square and then calling console.log. And then at the bottom of our file, we actually run print square. Right? This code all good? Make sense? So if we run this, well, I should back up a step, sorry. So the call stack is basically it's a data structure which records basically where in the program we are. So if we step into a function, we push something onto the stack. If we return from a function, we pop off the top of the stack. That's all the stack can do. We push stuff on the top, pop off the top. So if we run this file, well, there's kind of a main function, right, like the file itself. So we push that onto the stack. And we have some function definitions. They're just defining the state of the world. And then finally we get to print square, right? So print square is a function call, so we push that onto the stack. And immediately inside print square, we're going to call square, which we're going to push onto the stack, which calls multiply. And now we hit a return statement, right? We multiply A and B, and we return. So I said, when we return, we pop something off the stack. So pop, multiply off the stack, return into square, return to print square, console.log. Print square is now, there's no return, but it's implicit because we got to the end of the function, and we're done, right? So that is like a visualization of the call stack. Does that make sense? Yes, well, okay, great. So even if you haven't really thought about or visualized the call stack before, you've undoubtedly come across it when you've been doing certainly browser-side development. So if we have code like this, a function baz, which calls bar, which calls foo, which throws an error, then if we run this in Chrome, we see something like this in the DevTools, right? Uncall error oops, and it prints the stack trace. That is the stack trace, right? The state of the stack when that error happened. So uncall error oops, which was called in foo, which was called by bar, which was called by baz, which is called by this anonymous function, which is our main, right? Equally, if you've heard the term blowing the stack, then this is an example of that, right? Have a function foo which calls foo. So what's going to happen? Well, we run main, we call foo, which calls foo, which calls foo, which calls foo, and ultimately Chrome says, well, you probably didn't mean to call foo 16,000 times recursively, so I'll just kill things for you, and you can figure out where your bug lies, right? So although I may be representing a new kind of side of the call stack, you've probably got some sense of it in your development practice already. So the big question then comes is what happens when things are slow? So we talk about blocking and blocking behavior, and blocking, there's no strict definition of what is and isn't blocking. Really, it's just code that is slow, right? So console.log is not very slow. Doing a while loop from 1 to 10 billion is kind of slow. Doing image processing is slow. Network requests are slow. So things which are slow and on that stack are what blocking means. So here's a little example. So let's say we have, this is like a fake bit of code, get synchronous, right? Like jQuery's like AJAX request. What would happen if those were synchronous requests? So forget what we know about async callbacks, they're synchronous. So if we just go through it like we have been, we call get sync, and then we wait, right? Because we're doing network requests. Networks relative to computers are very, very slow. Hopefully that network request completes. We can move on, wait, move on, wait. And I mean, this network request might never finish, so yeah, I guess I'll go home. Finally, those three blocking behaviors complete, and we can clear the stack, right? So in a programming language which is single-threaded, you're not using threads like, say, Ruby, like that's what happens, right? We make a network request, we have to just wait till it's done because we have no way of handling that. So why is this actually a problem? The problem is because we are running code in browsers. So let's, why can't I, here we go, okay. So this is just, this is Chrome. This is the code I just ran. Browsers don't give us, well, they do actually give us synchronous AJAX requests, but I'm actually just faking this out with a big while loop, because while loops are synchronous. So I basically while loop for like a second or 5 seconds, I think, before continuing. So if I open up the console here, we can see what happens. So we request free.com, and like, while this is happening, I can't do anything, right? Like, even the run button hasn't finished re-rendering the fact that I previously clicked it, because the browser is blocked. It's stuck. It can't do anything until those requests complete, and then all hell breaks loose, right? Because I did some stuff, and it figured out that I'd done it, it just couldn't actually like render it, couldn't do anything. And that's because if that call stack has things on it, and here it's got these, yeah, it's still doing, we've got these synchronous requests, right? We've blocked the call stack. The browser can't do anything else. It can't render it. It can't run any other code. It's stuck. Not ideal, right? If we want people to have nice fluid UIs, we can't block the stack. So how do we handle this? Well, the simplest solution we're provided with is asynchronous callbacks, right? So there are almost no blocking functions in the browser. It's equally no, they're all made asynchronous, which basically means we run some code, give it a callback, and we run it later, right? We know what, if you've been writing JavaScript, you've seen asynchronous callbacks. What does this actually look like? So simple example to remind people just where we're at. Code like this, console.log hi, right? We run this at timeout, but that queues the console.log for the future somehow. So then we skip straight onto JS.view, log that, and then 5 seconds later, we log there, right? Make sense? Happy? Basically, like that set timeout is doing something. So asynchronous callbacks with regards to the stack we saw before, how does this work? So let's run the code. Console.log hi, set timeout. Okay, what's going to happen here? We know that console.log there doesn't run immediately. It's going to run in 5 seconds time. We can't push that console.log onto the stack. So somehow it just disappears. We don't have like a way of describing this yet, but we'll come to it. We log JS.view, clear, and then 5 seconds later, somehow magically console.log there appears on the stack. How does that happen? And this is basically where the event loop comes in, and concurrency. Right? So I've been kind of partially lying to you and telling you that JavaScript can only do one thing at a time. That is true. JavaScript, the runtime, can only do one thing at a time. It can't make an AJAX request while you're doing other code. It can't do a set timeout while you're doing other code. The reason we can do things concurrently is that the browser is more than just the runtime. So remember this diagram. The JavaScript runtime can do one thing at a time, but the browser gives us these other things, right? It gives us these web APIs. These are effectively threads that you can't access like threads. You can just like make calls to. And those pieces of the browser are where this concurrency kicks in. If you're a backend person, this diagram looks basically identical for Node, except instead of web APIs, we have C++ APIs, right? And the threading and all that stuff is hidden from you by being run in like C++ land. Okay, so now that we have this picture, let's see how this code runs in this kind of more full picture of what a browser looks like. So, same as before. Run the code, console.log hi to console. Simple. Now we can see what happens when we call set timeout. So when we call set timeout, we pass this callback function and a delay to the set timeout call. Now set timeout is an API provided to us by the browser. Remember I said it doesn't live like in the V8 source. It's like extra stuff we get in the environment we're running the JavaScript runtime in. So effectively, we kick off a timer, right? Like the browser kicks off a timer for you, and now it's going to handle the countdown for you, right? So that means that our set timeout call itself is now complete, so we can pop off the stack. JS.view, clear. So now we've got this timer in the web API, which 5 seconds later is going to complete. Now the web API can't just like start modifying your code, right? It can't just like chuck stuff onto the stack when it's ready, because if it did, it would like just appear randomly in the middle of your code. So this is where the task queue or the callback queue kicks in. So basically, any of the web APIs, when they're done, they push your callback onto the task queue. And finally, we get to the event loop. The title of the talk is what the heck is the event loop. The event loop is like the simplest little piece in this whole equation, and it has one very simple job. The event loop's job is to look at the stack and look at the task queue. If the stack is empty, it takes the first thing on the queue and pushes it onto the stack, which effectively runs in, right? So here we can see that now the stack is clear. There's a callback on the task queue. Our set timeout call itself is now complete, so we can pop off the stack. JS.view, clear. So now we've got this timer in the web API, which 5 seconds later is going to complete. Now, the web API can't just like start modifying your code, right? It can't just like chuck stuff onto the stack when it's ready, because if it did, it would like just appear randomly in the middle of your code. So this is where the task queue or the callback queue kicks in. So basically,
Oh, mais c'est pour le follow.
any of the web APIs, when they're done, they push your callback onto the task queue. And finally, we get to the event loop. The title of the talk is what the heck is the event loop. The event loop is like the simplest little piece in this whole equation, and it has one very simple job. The event loop's job is to look at the stack and look at the task queue. If the stack is empty, it takes the first thing on the queue and pushes it onto the stack, which effectively runs in, right? So here we can see that now the stack is clear. There's a callback on the task queue, so the event loop runs. It says, oh, I get to do something here. Pushes the callback back onto the stack. Now remember, the stack is like JavaScript land, right? This is back inside V8. So the callback appears on the stack and gets run, console.log there, and we're done. Does that make sense? Everyone with me? Awesome. Okay. So now we can see how this works with probably one of the first encounters you have had with async stuff, which is when for some weird reason someone says, oh, you have to call set timeout 0. Like, okay, you want me to run the function in 0 time. Why would I wrap it in a set timeout? Like the first time you come across this, if you're anything like me, you're like, okay, well, I sort of see this doing something, but I don't really know why. And the reason is, generally, if you're trying to defer something until the stack is clear, right? So we know looking at this, if you've written JavaScript, that we're just going to see the same result. We're going to see hi, we're going to see JS.view, and then there's going to somehow appear at the end. So running it, we can see how that happens. Console.log hi, set timeout 0. Now it's going to complete immediately and push the callback onto the queue. But remember what I said about the event loop. It has to wait until the stack is clear before it can push the callback onto the stack. So your stack is going to continue to run, right? Your main file is going to continue to run, console.jsconf.u, and clear. Now that we're clear, the event loop can kick in, run your callback. So that's like an example of set timeout 0 is like deferring that execution of code for whatever reason to the end of the stack, or until the stack is clear. Okay. So all these web APIs work the same way, right? If we have AJAX requests, we make an AJAX request to a URL with a callback, just works the same way. Console.log hi, make an AJAX request. The code for running that AJAX request does not live in the JavaScript runtime, it lives in the browser as a web API. So we spin up a XHR web API with a callback in the URL. Your code can continue to run until the XHR request completes, or doesn't complete. It may never complete, but that's okay. Your stack can continue to run. Assuming it does complete, callback gets pushed onto the queue, picked up by the event loop, and it's run. Right? That's all that happens when an async call happens. Okay, so let's do a crazy complicated example. So I hope this is going to work. If you hadn't kind of realized, like, all this is all in Keynote, there's like, I don't know how, like 500 animation steps in this whole deck. So hopefully that,
Hi. What's going on?
So, interesting. We're given a link. Is this big enough? Can people see? Okay, so basically I wrote this talk for Scotland.js earlier in the year, and I did it there. And then after the talk, I broke half of the slides and could not be bothered to redo all the slides because it was a total pain in the ass in Keynote to do it. So instead, I took the much easier route of writing a tool which can visualize the JavaScript runtime at runtime. And it's called Loop. So let's just run this example, and which was kind of the example we had on the previous slide. I haven't shimmed XHR yet. It's doable. I just haven't done it. So as you can see the code, we're going to log something. This is a simple shim around like document.add-event-listener. Set timeout, and we're going to do a console log. So I'm just going to run it and see what happens. So add a DOM API, add a timeout. Timeout's going to count down. Code's going to continue to run. Pushes the callback into the queue, which runs a console.log, and we're done. If I click on here, then it's going to trigger the web API, key the callback with a click, and run it. If I click 100 times, we can see what happens, right? I've clicked. The click doesn't get processed immediately. The click gets pushed onto the queue, and as the queue gets processed, eventually my click is going to get dealt with, right? So I have a few more examples I want to run through here.
Gonna get dealt with, right? Nee, il utilise
so I have a few more examples I want to
using jQuery. Don't. Okay.
Okay. So I'm just going to run through a few examples just to kind of talk about a few things that you might have run into and not kind of thought about with async APIs. So in this example, we call set timeout 4 times with a 1 second delay and run console.log hi. So if we run it, we can see that we run a few timeouts, but the timeout callbacks get queued. Right? So that fourth callback, we asked for a 1 second delay, and it's still waiting. The callback hasn't run, right? So this kind of illustrates what set timeout's actually doing. Set timeout is not a guaranteed time to execution, it's a minimum time to execution. Just like set timeout 0 doesn't run the code immediately, it runs the code next-ish sometime, right? So in this example, I want to talk about callbacks. So depending on who you speak to and how they phrase things, callbacks can be one of two things. Callbacks can be any function that another function calls, or callbacks can be more explicitly an asynchronous callback, as in one that is going to get pushed onto the callback queue at some point in the future. So this little bit of code illustrates the difference, right? The for each method on an array, it doesn't run, it takes a function, which you could call a callback, but it's not running it asynchronously, right? It's running it within the current stack. We could define an asynchronous for each, so we could, it's going to take an array and a callback, and then for each item in the array, it's going to do a set timeout 0 with that callback, right? I guess this should actually pass in the value, but anyway. So I'm going to run it, and we can see what the difference is. So for the first block of code that runs, it's going to sit and block the stack, right? Until it's complete. Whereas in the async version, okay, it's slowed down, but we're basically going to queue a bunch of callbacks, and they're going to clear, and then we can actually run through and do the console.logs. So in this example, the console.log is fast, so the benefit of doing it asynchronously isn't obvious. But let's say you're doing some like slow processing on each element in the array. I think I have that shown somewhere. No, I don't. Okay. So let's say, oops. So I have a delay function, which is just slow, right? It's just a slow thing. So let's say processing async, and here, processing sync. Okay, now I'm going to turn on a thing I've just been literally hacked together this morning, which is to simulate the repaint or the render in the browser. So something I haven't touched on is how all of this interacts with rendering. I kind of touched on it, but yeah, not really explained it. So basically, the browser is kind of constrained by what you're doing in JavaScript, right? The browser would like to repaint the screen every 16.6 milliseconds, right? 60 frames a second is our ideal, like, that's as fast as it will do repaints if it possibly can. But it's constrained by what you're doing in JavaScript for various reasons. So it can't actually do a render if there is code on the stack, right? It's like the render kind of call is almost like a callback itself, right? It has to wait till the stack is clear. Now the difference is that the render is given a higher priority than your callbacks. So basically every 16 milliseconds, it's going to queue a render, and then it's going to have to wait till the stack is clear before it can actually do that render. So this render queue is just simulating a render, right? So every second it's like, can I do a render? Yes. Can I do a render? Yes. Can I do a render? Yes. Because our code isn't doing anything now. However, if I run the code, we can see that while we're doing this like slow synchronous loop through this array, our render is blocked, right? And if our render is blocked, you can't select text on the screen. You can't click things and see the response, right? Like that example I showed earlier. In this example, okay, it's blocked while we queue up the async timeouts, but that's relatively quick. but we're kind of giving the render a chance between each element because we queued it up asynchronously to kind of jump in there and do the render. Does that make sense? Yeah, cool. So yeah, that's just kind of, this is just like a simulation, right, of how the rendering works. But it just really shows you, like, when people say don't block the event loop, this is exactly what they're talking about. They're saying don't put shitty slow code on the stack, because when you do that, the browser can't do what it needs to do, which is like create a nice fluid UI, right? This is why doing things like image processing or whatever, or like animating too many things just gets kind of sluggish, right, if you're not careful about how you queue up that code. So an example of that, we can see scroll handler. So scroll events in the DOM trigger a lot, right? Like they trigger like I presume they trigger on every frame, so like every 16 milliseconds. So if I have code like this, right, on document.scroll, animate something, or do some work. If I have this code, like as I scroll, it's just going to queue up like a ton of callbacks, right? And then it has to like go through and process all of those. And if each of the processing of those is slow, then okay, you're not blocking the stack, but you're kind of flooding the queue with events, right? So this is like just helping visualize, I guess, like what happens when you actually trigger all these callbacks. So there's ways you can like debounce that to basically say, okay, we're going to like queue up all those events, but let's only do this slow work every few seconds or until the user stops scrolling for some amount of time. Cool. So I think that's basically it. There's like a whole other talk.
Bon, j'ai compris au début, mais à la fin, je suis perdu. Non, mais bon, voyons voir. Est-ce qu'il y a des essais sur ça? Je vois si fonctionnement c'est ça. Bon, je pense que je vais éviter de commencer. Ok, regardez cette île callback execution. Write a function that takes a callback and invoke it after a delay of 2 seconds. Ok. Et aussi that no power distribution promises. I think I'll just take this one like that.
Promises in JavaScript are known to be a little daunting, intimidating, annoying, I don't know, whatever negative thing you want to say about them. But I promise you that once you understand what happens behind the scenes.
Ouais, c'est bon, à la fin, au début, je compris l'explication, mais à la fin, j'étais perdu. Mais je pense que je vais juste faire quelques exercices et voir. Mais au début, je voulais d'abord comprendre comment si ces promises travaillent, tout ça. Donc pour ça, il va falloir faire un petit code un peu comme ça. Mais après, bon, je pense que je vais regarder d'autres vidéos et voir.
Under the hood, they're actually not that complicated. So today, I want to walk you through promise execution and see what happens behind the scenes when you interact and work with promises. So one way to create a promise is by using the new promise constructor. And this constructor also receives an executor function. Now, when the new promise constructor is executed, a new promise object is created in memory. And this object contains some internal slots, like the promise state, promise result, promise fulfill reactions, promise reject reactions, and promise is handled. We also get some additional functionality to either resolve or reject this promise. Now we can resolve this promise by calling resolve, which is made available to us by the executor function. And when we call resolve, the promise state is set to fulfilled, and the promise result is set to the value that we pass to resolve, so the string done in this case. Similarly, we can reject the promise by calling reject, in which case the promise state is set to rejected, and the promise
Ouais, c'est ça. Parce que c'est... Bon, je sais que c'est la première fois. La syntaxe est un peu bizarre. Bon, la syntaxe pour moi est un peu bizarre, donc c'est ça. Bon, mais c'est sûr que je dois apprendre ça. Mais je dois un peu comprendre ça pour faire, je pense, l'application de météo. Comme ça, je vais pouvoir utiliser l'API pour la météo et tout ça. Donc,
Now what happens is that whenever we resolve the promise, so we call resolve, resolve is added to the call stack, the promise state is set to fulfilled, promise result is set to the value that we pass to resolve, and the promise reaction records handler receives that promise result. So
Ok, au moins ça, je pense avec ça, avec l'exemple qui est donné, ça peut être utile.
when we interact and work with promises. So one way to create a promise is to use a new promise constructor, and this constructor also receives an executor function. Now when the new promise constructor is executed, a new promise object is created in memory, and this object contains some internal slots like the promise state, promise result, promise fulfill reactions, promise reject reactions, and promise is handled. We also get some additional functionality to either resolve or reject this promise. Now we can resolve this promise by calling resolve, which is made available to us by the executor function. And when we call resolve, the promise state is set to fulfilled, and the promise result is set to the value that we pass to resolve, so the string done in this case. Similarly, we can reject the promise by calling reject, in which case the promise state is set to rejected, and the promise result is set to the value that we pass to reject, so the string failed. Cool, nothing special here. We're just calling a function to change some object property. So what's so special about promises? Well, that's actually in those two fields that we skipped so far. So in the promise fulfill reactions and the promise reject reactions, because these fields contain something called promise reaction records. We can create a promise reaction record by chaining a then or a catch method to the promise. So whenever we chain then, the then method is responsible for creating that promise reaction record. And among many other fields, this reaction record contains a handler. And this has some code, and that code is that callback that we pass to then. Now what happens is that whenever we resolve the promise, so we call resolve, resolve is added to the call stack, the promise state is set to fulfilled, promise result is set to the value that we pass to resolve, and the promise reaction record's handler receives that promise result, so the string done in this case. And the handler is now added to the microtask queue. This is where the asynchronous part of promises comes into play. And just kind of as a quick refresher, whenever the call stack is empty, the event loop first checks in the microtask queue. And whenever this queue is empty, it goes to the task queue, also called like the callback queue, macro task queue, whatever you want to call it. What's important here is that the microtask queue gets priority. Now, so far, I've only been
Putain, père.
the event loop, and just kind of as a quick refresher, whenever the call stack is empty, the event loop first checks in the microtask. Quick refresher. Whenever the call stack is empty, the event
Oh,
loop
j'ai une
first
question.
checks in the
Attends,
microtask.
la différence entre task et microtask. Ça alors, pourquoi il a pas mis ça? Bon, ouais, on va ça. Ouais.
Refresher. Whenever the call stack is empty, the event loop first checks in the microtask queue. And whenever this queue is empty, it goes to the task queue, also called like the callback queue, macro task queue, whatever you want to call it. What's important here is that the microtask queue gets priority. Now, so far, I've only been calling resolve and reject synchronously, like right in the promise constructor, but usually you want to initiate some kind of asynchronous task in this constructor. With an asynchronous task, I mean anything off the main thread, so reading something from a file system or a network request or something as simple as a timer. Whenever they return that data, we can use their callback function to either resolve with the data that they returned or reject if an error occurred. So just to keep it simple, let's see how the execution goes for this promise constructor. So we have the promise constructor that has a set timeout, and we also have a then handler. Let's just go through it step by step and see what happens. So first, the new promise constructor is added to the call stack, and this creates the promise object. The executor function is called, and on the first line we have a set timeout. So set timeout is added to the call stack, and this one is responsible for scheduling that timer. In this case, 100 milliseconds. And this has that callback that we pass to set timeout, so the function that eventually calls resolve. Then on the next line, we have the then handler. So then is added to the call stack, and this is responsible for creating that promise reaction record. So this creates a promise reaction record with the callback that we provided as its handler. Now then is popped off the call stack, and let's just imagine that those 100 milliseconds are up now. So the callback that we passed to set timeout is now added to the task queue. There's nothing on the call stack anymore, script is finished, so it can now go from the task queue to the call stack. And this now calls resolve, so this changes the promise state to fulfilled, the promise result to the string done, and it schedules that handler to the microtask queue. Resolve is now done, popped off the call stack, so is the callback, and there's again
Attendez.
promise priority
Attends.
now spilling that timeout. is added to the call stack, and this one is responsible for scheduling that timer. In this case, 100 milliseconds. And this has that callback that we passed to set timeout, so the function that eventually calls result. Then on the next line, we have the then handler. So then is added to the call stack, and this is responsible for creating that promise reaction record. So this creates a promise reaction record with the call.
Ok, je vois. Ça veut dire que le fait tu appelles then, et ça fait le resolve. Ok.
Stack that we provided as its handler. Now then is popped off the call stack, and let's just imagine that those 100 milliseconds are up now. So the callback that we passed to set timeout is now added to the task queue. There's nothing on the call stack anymore, script is finished, so it can now go from the to the call stack. And this now calls result, so this changes the promise state to fulfilled, the promise result to the string done, and it schedules that handler to the microtask queue. Resolve is now done, popped off the call.
Bah, moi, je pensais que Resolve était fini ici parce que là, le nom, ça devait s'afficher done. Attends, Resolve, ça pète juste la fonction. Ok.
Stack, so is the callback, and there's again nothing on the call stack, so the event loop first checks the microtask queue. Well, there are handlers moving, so the handler is added to the call stack, and this then console logs the promise result, which is the string done. Now, the nice thing about the fact that it's added to the microtask queue is that in the meantime, our script can just keep running. It can just keep performing important tasks, and it stays in rest. Only when the call stack is empty, so when there's like nothing important to do, does it get added to the call stack from the microtask queue. So this means that we can handle the promise result in a non-blocking way. Now, another cool thing is that then itself also returns a promise. So besides just creating that promise reaction record, it also creates a promise object. And this allows us to kind of chain those thens to each other and have this incremental promise results handling. So let's just see what happens when we have this code snippet. So the first we have the new promise constructor, which creates that promise object. This immediately resolves with 1, so the state is set to fulfilled and promise result is 1. Then we call the then handler, so this creates a promise reaction record with the handler being result, and then it returns result times 2. Result being that promise result, which is the number 1. But it also creates a promise object, and this is now set to fulfilled because we returned result times 2. Result being 1, so result times 2 is 2. And we do the same on the next line, so we have another then. This creates a promise reaction record again with the exact same handler, so result times 2. This time result being 2, so 2 times 2 is 4. So this promise result is now 4. And then we have one more, and this just logs that value. So again, the state is set to fulfilled. In this case, the result is undefined because we didn't return a value, we're only logging it. But in the console, you will see 4. So that's just something to keep in mind. We can chain those thens together and kind of incrementally handle that promise result in a non-blocking way. Now, of course, in a real application, you won't use numbers like this, but instead you want to incrementally handle that promise result. Maybe you have some kind of image that you first want to resize and then add a filter and then change the format. I don't know what you want to do with an image, but you can do all that by chaining this then in a non-blocking way. And that's pretty cool. That's pretty powerful. All right, so let's see how well you understand promises, or at least how well I explained it. So pause this video real quick and see if you...
Bon, sérieusement, ça me casse les couilles. Ok, on va juste voir. Ça écrit. Puis, est-ce que je peux directement appeler un résultat sans utiliser? Oh. Bon, voyons voir. Then result, machin, si ça résolve ça. Ça écrit, c'est gardé. Ah, je savais pas qu'on pouvait, on pouvait directement appeler une fonction dans un peu. J'ai créé ça. Oh. Ok, je regarde ici. Un peu, je fais un truc. Ça peut-être là. Ah, ok, qu'est-ce qui va s'afficher en premier? Ok, je regarde ça. Ok. Bon, ça veut dire que dans un premier, on peut directement afficher un résultat. Alors, ça veut dire que ça est créé en premier. Bon, moi, j'ai ma logique. Ça est créé. Il y a one, TV et tout. Parce que ça est en premier. Comme si mon résultat, c'est waiting for the user to watch video. On sait que le premier, ça serait d'abord one. Ok. Après, premier, ça serait un. Puis on fait un resolve de tout. Then ça serait stocké, ça serait gardé. Puis ça appelé après. Bon, j'espère que c'est ça. Oh, j'espère que c'est ça. J'ai bien dit. Mais c'est juste que. Attends, sur son dessin. C'est ça, je comprends pas. Attendez. Premier résolve si exto est gardé. Parce que c'est que c'est le 1. Ça est affiché. Puis. Non, je sais pas. Ah, ça c'était la logique, mais je pas compris. C'est juste bizarre. Ouais, c'est ça qui est affiché. Oui.
Then we call resolve with 2. So now the promise state is changed to fulfilled. The promise result is set to 2. And we don't have a promise fulfill reaction yet. That only happens on the next line. Resolve is popped off the call stack. So is the executor function and the new promise constructor. Now on the next line we finally have then. So this creates the promise reaction record. It doesn't get added to that list because the promise is already resolved. This would just take up unnecessary memory, but it still has access to that promise result. So this promise reaction record has the handler with the result being 2 and then console log result. So this
Ok, bon, si je comprends bien, ça veut dire que tous les trucs qui sont dans, et je sais pas si c'est Den et Catch, sont d'abord passés dans un micro. Oh, fait que ça.
important to remember that it's not immediately executed. No, it is immediately scheduled to the microtask queue. Then we go to the next line because our script isn't done yet. The call stack isn't empty yet. And there we just call console log 3 in a normal way. So this is added to the call stack, logs 3. So now we have 1, 3. Now finally our script is done. There's nothing on the call stack. So the first task in the microtask queue is added to the call stack, which is that then handler, which then console logs the result being 2. So now finally 2 gets logged. Hopefully my explanation.
Ok, bon, voyons voir si je vais utiliser son exemple. Ok. Bon, si je comprends bien, ça veut dire que ça, c'est pas directement exécuté. Ça veut dire que bon, sa vidéo était quand même utile. Ok, bon, si je vais afficher. Bon, pour ça, je mets ça. Je pense que je vais prendre son dessin ici. I think I'll take this thing. Ok, ça serait un peu utile pour un moment. Bon, allez, on va. Ok, je copie. Je cut ça. Oh non, c'est parti. Il fallait comprendre la différence. Mais c'est que c'était quand même. C'est une bonne vidéo avec le visuel et tout ça. Je pense que j'ai quand même retenu un petit truc. Bon, c'est un peu. Premier 6, je garde ça là. Ok, bon, mais sa vidéo était quand même bonne. Non, sa vidéo est bien. Ça a expliqué quelque chose. Mais c'est lorsqu'il y a delay, c'est qui m'énerve, c'est ça. Lorsqu'il y a time out qui est... Je sais pas trop. Je pense que je vais voir. Where is the blog post? Oh, c'est bon. Bon, avec mon exemple, je pense que je compris pas maintenant. Essayons d'ajouter un delay. Pour ajouter ça où? Hmm? Je fais un peu un truc. Bon, et je coupe ça. C'est timeout. Je mets ça. Attends, cette timeout prend deux paramètres, si je comprends bien. Attendez un peu, je fais des recherches. Attends. C'est un map. Il y a code en des délais. Ok, c'est que si j'ai pas besoin d'entrer la fonction. Bon, je prends ça, couper et venir ici. Je mets mon code. Puis je mets un delay de 200. Oh, on se regarde. Qu'est-ce qui va s'afficher en première? Bonne question. Ok. Alors, je sauvegarder, j'ai pas vu. Attendez, voir. Je comprends pas. Pourquoi? Bon, dès que ça vient, ça prend ça. Et ça garde. C'est 5 secondes ou bien millisecondes. Oh shit. Bon, il faut. Bon, every ends millisecondes. Ok, c'est que c'est 5 secondes. Bon. Oh, je passe en dessin. Attends, je comprends pas. Wait for the user to push to your work, c'est ça. On fait une casse. Cette timeout, ça exécute ça. Pour 6 secondes, on se prend sa garde, ça continue le code, ça fait tout. Bon. Bon, je fais un peu qui m'explique un truc. Parce que moi, dans ma logique, je pensais que cette timeout devait attendre. Bon, explique ce que... Ok, alors je vais voir ce qu'il va me dire. Bon, je pense que j'ai mal posé ma question. Ok, bon, je prends la deuxième réponse, je préfère ceci. Ok, what is the first result? Ok, ah, c'est vrai. Bon, ça veut dire que ça n'a pas fonctionné parce qu'ici il disait que this line doesn't delay the message. Bon, ça veut dire que ça ne fait rien. Pourquoi? It's been executed immediately, not after you're passing the result. Bon, c'est là que ça ne delay pas. Ok, qu'est-ce que je peux faire? Ah, je peux mettre une fonction. Je pense que je peux mettre une fonction. Ok, après je mets ça ici. Oh shit, qu'est-ce que je fais? Non. C'est ça. Ok, bon, je vois, c'est que je vais mettre ça dans une fonction. Bon, j'étais sûr. Je peux pas directement mettre ça. Bon, ça veut dire on va réussir. Là, on actualise. Ça va d'abord exécuter by, ça va exécuter tout. Vu que ça c'est 5 secondes, puis ça va venir exécuter 1 seconde. Ouais, ça peut être logique. Bon, c'est quand même intéressant, meurt. Ok, on va faire un truc. Et si je vais changer la valeur comme on me propose là. Bon, je peux changer la valeur, ça ne change rien. Bon, au moins j'ai quand même compris la logique de problème de ce second pass, ça veut dire. Il faut vraiment le dessin ici. Donc, est-ce qu'il n'y a pas moyen de voir la façon que ton code est exécuté? Bon, visualize event loop. Je pense.
The event loop is a pretty notorious topic in JavaScript, but when we zoom out, it's just a tiny component within the JavaScript runtime. We also have the call stack, we have web APIs, we have the task queue, microtask queue, and then eventually the event loop. Well, to be a little more technically accurate here, we actually have the JavaScript engine, in which we have the call stack and then also the memory heap, but to keep my slides a little organized, I'll just be showing the call stack here. All these components together allow us to use asynchronous tasks in a non-blocking way in JavaScript. And this is important because JavaScript itself is single-threaded. We're only working with a single call stack. So the call stack manages the execution of our program. So if we have the following script, we first have console log 1. So a new execution context is created, pushed onto the call stack, which is then evaluated and logs 1. Then we have console log 2, same story. Execution context is created, pushed onto the call stack, is evaluated, and logs 2. Then on line 14, we invoke another function, the log 3 and 4. And within this function body, we invoke yet another function, log 3. And within log 3, we invoke another function, the console log 3. Eventually it logs 3. Then on the second line within the log 3 and 4 function body, we console log 4. 4 gets logged, and now the log 3 and 4 execution context is popped off the call stack as well. Now something important to remember here again is that JavaScript can handle a single task at a time. So if we, for example, had this long running task in which we have a pretty heavy computation, it takes a while before JavaScript can continue with the rest of our program. So the console log long task done is only logged after a couple seconds. And this is not what we want because in the meantime, our entire program is frozen. So we want to avoid these long running tasks. But in a real life application, we often have to use these long running tasks like maybe a network request or anything based on user input, timers. So what happens then? Like, is our entire call stack just blocked until we get the data back? No. because we're actually using web APIs in those cases. And web APIs provide a set of interfaces that allow us to interact with the browser's features. This includes functionality that we often use, like the document object model, fetch, set timeout, and so many more. The browser is a very powerful platform with a lot of features. Some of these features are required, like the rendering engine or the networking stack. But we also have access to some cooler ones, like device ones, sensors, cameras, geolocation, and so on. Okay, cool, but what does this have to do with long-running tasks? Well, some of these web APIs allow us to offload long-running tasks to the browser. So when we invoke such an API, we're kind of just initiating that offloading. And web APIs that expose these asynchronous capabilities are either callback-based or promise-based. So first, let's focus on the callback-based APIs, and I'm just going to use the geolocation API because it's fun. I could have used any other callback-based API, but let's say that we want to get the user's location. And for this, we can use the getCurrentPosition method exposed by the geolocation API. And this receives two callbacks. First, we have the success callback in case everything goes well and the user allows us to get the location and we actually get it from the browser, or the error callback in case anything goes wrong. So let's see what happens when we actually use this in our script. So first, the getCurrentPosition invocation gets added to the call stack. However, this is just to register those callbacks and initiate that async task. After doing that, it can get popped off the call stack immediately, so it doesn't wait for any data. Now in the background, the browser starts some kind of process that eventually shows the user a pop-up. Now of course we don't know when the user is going to interact with this pop-up, but that's not a problem because this is not happening on the call stack, so our entire website is still responsive in case other tasks need to run instead. Now finally, the user clicks on allow. So the API receives the data from the browser and uses the success callback to handle this result. However, it can't just push that callback back onto the call stack. This could disrupt an already running task and just create very unpredictable behavior. So instead, the callback gets pushed to the task queue, which is also called the callback queue for this exact reason. The task queue holds web API callbacks and event handlers to be able to get executed at some point later in the future.
Oui, c'est ça. Je pense que je devais d'abord voir la vidéo avant de voir ma vidéo aussi. Parce que là, ça explique
This is
le
where
code.
we finally get to the event loop. It's the event loop's responsibility to check if the call stack is empty. And if that's the case, so if nothing is running, it then gets the first available task from the task queue and moves this to the call stack where it's executed. So now finally, we handle the results and the user's location is logged to the console. Another very popular callback-based web API is set timeout. And set timeout also receives a callback
Okay.
very popular.
C'est pas comme ça qu'on écrit ça. Ah. Ok, bon. Oh, je vois maintenant, je comprends. Ah, je vois. Ok, premier sketch frontend. Ok, ça veut que ça part dans le micro-task et c'est prioritaire. Ok. Désolé. Le micro-task on the queue is empty. Then pick one task from the text on it repeat the cycle. constate. Bon. Et si je dis constate, oui, là ça met en timeout 0. Pour mettre ces soldes de 10. Macro, micro. On sait qu'il y a l'exemple timeout setting to value event. Bon, ce sont les failles. Ok, alors ça peut être intéressant. Before text, cut inline before text. On continue.
Their callback-based web API is set timeout. And set timeout also receives a callback and a delay. So let's see how that works. So first we encounter a set timeout. And this again gets added to the call stack, but all it does again is register that callback and also the delay with the timers API. And in the background, the browser will actually handle that timer. Then we have another set timeout, and again, it registers the callback and the delay. Now our timers are still running, and we have a console log end of script. This just gets added to the call stack and logs end of script, nothing asynchronous here. Now after 100 milliseconds, the browser was like, hey, 100 milliseconds expired. So now the callback moves onto the task queue. There's nothing on the call stack right now, so this moves onto the call stack where eventually it logs 100 milliseconds. Now 2000 milliseconds are up. Again, same story. The callback is pushed onto the task queue. Call stack is empty, so it moves onto the call stack where it logs 2000 milliseconds. So it's just very important to remember that when you have a set timeout and a delay, it's not the delay until it gets moved onto the call stack. No, it's the delay until it gets moved to the task queue. So this means that the delay that we specify might not actually be the delay to execution. Because if the call stack was still very full with other tasks and this could run for many more seconds, the callback would still have to wait in the task queue until the call stack is empty.
Non, je vois.
To keep in mind. So long story
Ok.
short, the callback
Bon,
provided
je
by
pense
the
on va encore
APIs
prendre un
are
exemple.
pushed onto the task queue when asynchronous task completes. So what about the promise-based ones? If you haven't checked out my promises video yet, I highly recommend you watch it because I'll just assume some basic promise knowledge while explaining this entire flow. Whenever we work with promises, we're working with the microtask queue. The microtask queue is a special queue dedicated to then catch finally callbacks, a function body execution after await, the queue microtask callback, and the new mutation observer callback. So only those callbacks or those function body parts get pushed onto the microtask queue, so it's very specific. However, the event loop prioritizes the microtask queue. So whenever the call stack is empty, the event loop first ensures that the microtask queue is entirely empty. So it gets all the tasks from the microtask queue, moves them onto the call stack where they get executed, and only then will it move to the task queue. And after each task in the task queue, it again checks the microtask queue. And a popular promise-based web API is fetch. So let's see what happens behind the scenes when we invoke fetch. So whenever we call fetch, it's added to the call stack. This is just responsible for creating a promise object, which by default is pending. The result is undefined, and we don't have any promise reactions just yet. It also initiates that background network request that's handled by the browser. Then we move on to the next line, we have the then handler. And this creates a promise reaction record where we have res console log res. The server still hasn't responded, by the way, but we get to line 4. So there we have a synchronous console log end of script. So now end of script is logged to the console. And then finally, the server returns some data. So now the promise state is set to fulfilled. The promise result is now the response object with the data that we got from the server. And the promise reaction handler is now also pushed to the microtask queue, right? Because it's a then callback and that gets pushed to the microtask queue. The call stack is empty, so the event loop checks the microtask queue, moves this to the call stack where it eventually logs the result that we got from the server. Something to keep in mind with microtasks is that a microtask can also schedule another microtask. And this means that the event loop is just constantly handling the microtask and it can never actually get to the task queue. It would just have to wait indefinitely. So we're kind of creating an infinite loop, an infinite microtask loop freezing our entire program. I believe in Node you can set like max tick depth or something like that, which prevents this exact thing from happening. But just make sure that you don't accidentally end up doing that. And we can also promisify a callback-based API. So for example, we can wrap the getCurrentPosition with a new promise constructor. And for the success callback and the error callback, we just pass resolve and reject. So this can be a pretty nice solution just to improve the readability within your code base a bit. All right, a little quiz to see if you kind of understand it. So we have a promise resolve with a then handler. We have a set timeout. We have a queue microtask in which we have another queue microtask, and then we have a console log 5. It's up to you to see.
Bon, là c'est parti. Ok, Mr. Resolve. Then timeout. Bon. Promise of resolve timeout. Ça. Exécuteur, c'est mis dans le texte. Attends, où est mon dessin? I need my train type. Sticker. Ouais, je mets ça ici. Je sais. Bon, là c'est parti, on fait un test. Promise that is off, then cancel. Donc ça y est que là c'est passé dans le coaster. Puis le result est directement passé là. Ouais, parce que là je web API. Est-ce que ça c'est une API? Non, je pense pas. Ah, c'est parce que là c'est passé là. Cancel 1. Ouais. Pendant qu'on met là. Un timeout cancel de log 10 millisecondes. Là on met là. Et ça repasse là, ça attend 10 millisecondes. On savait que ici il y en aurait cancel de log 1. Ici c'est cancel de log 2. Ça attend 10 millisecondes, ça vient ici. Oui. Donc il y a deux tâches. Console 2. Attends 10 millisecondes. Ça veut dire que c'est rapide. Bon, voyons voir. Puis on a microtext qui apprend une fonction. Cancel.log. Là la fonction appelée. Je pense que ça va faire le cancel.log 3 directement. Ça va faire le... Bon, ce n'est pas encore appelé. La fonction appelée ici. Ouais. Ouais. Bon. Bah, je pense qu'il y a d'abord C. Attends, une question. Sa fonction c'est appelée où? Une question. Donc, on prend la fonction si cancel.log 3 que microtax, on appelle encore DLD. Bon, là on m'a perdu. Bon, ça serait 5. On va mettre 5. Puis on va récupérer notre 1. Je pense qu'on va récupérer notre 2. Je sais pas, c'est 5, 2, 1. Moi j'ai laissé 6 parce que je sais pas trop comment la fonction c'est fonction. Bon, quand ça doit être log 3. Et C'est la première fois que je vois, attends, une fonction qui est... La fonction si passe un callback function. Et le callback function fait quoi? Ça fait... Ça affiche console de log 3, désolé. 3 et encore s'appelle encore la fonction qui passe et callback function qui affiche console de log 4. Ça, je pense que ça est infini parce que comment? C'est quoi ça? Est-ce que c'est possible? Ok. Et je peux faire un test. Est-ce que c'est vraiment possible? Oh, bon, ok. On enchaîne ici. Bon, ok. Et je viens ici, si je vais appeler ma fonction. Ok. J'appelle encore la fonction. Et qu'est-ce que la fonction fait? Ça me fait. Et qu'est-ce que ça doit être log défaut. Ça, je prends ça. Je me mets ici. Reste sauvegarde, j'exécute mon code. Qu'est-ce que ça m'affiche? C'est juste bizarre. Ça, je me disais là-bas, il y a une erreur. Non, pourquoi ça me montre l'erreur? Bon, voyons voir. Ah, moi je dis c'est. Non, mais. Attends. Bon, et si je dirais. Oh, mon dessin. Ici. Attendez. Ça vient ici. Premier object pending. Parce que ça n'a pas sorti un resolved. Bon, premier resolve, then. Je pense que ça fait un resolve directement, mais ça attend. Bon, là ça vient ici. Promise reaction, ça serait quoi? Cancel the log one. Et ici, pendant que ça fait ça, ça affiche le cancel de log 2. Parce que là ça vient ici. Après ça vient en tax queue. Donc ici ça serait cancel de log 2. Ici ça serait 2 parce que bon c'est 10 millisecondes, donc ça ne va pas perdre le temps. Mais pendant que ça reste là, ça continue son travail. Ici, j'ai jamais vu ça. Moi, je pense qu'il y a une erreur ici. Parce que ça, c'est quoi? Alors, je sais pas, est-ce que c'est une méthode? Bon, moi, je dirais 5, 2, 1. Oh, je sais pas. Mais je pense que ça commence avec 5 et puis 2.
So pause the video now and let's see if you got it right. And the right answer is 5, 1, 3, 4.
Non, 2 à la fin.
So let's see why. First we have
Ok.
resolve, and this just creates a
Attendez un
promise
peu.
object that's instantly resolved. Then on the next line, we have the then handler. The promise is already resolved, so in the background it does create that promise reaction, but the handler is immediately pushed to the microtask.
Bon, ça quand même est logique. Ok.
Then we have set timeout, which is responsible for initiating that timer. So the callback and the delay get passed to the API, and in the background the browser starts some sort of timer. Then we have queue microtask. So the call is added to the call stack, and this queues that callback to the microtask queue. Then we have the synchronous console log 5, so this gets pushed to the call stack and logs 5. And in the meantime, the 10 milliseconds are up, so the callback from set timeout is
Ça vient ici.
because this was a callback-based API, so task queue. Our script is done, the call stack is empty, so the event loop checks the microtask queue. And there we have the promise handler callback. And this eventually calls console log 1, so 1 is logged to the console. Then we have the queue microtask callback, and within this callback we call console log 3, so 3 is logged to the console. Then we call another queue microtask, and this queues another microtask with its callback to the microtask queue. However, the event loop has to ensure that the microtask queue is entirely empty before moving on to the task queue. So that callback is immediately moved onto the call stack again and logs 4. Now finally, the call stack is empty and the microtask queue is empty. So the first available task from the task queue is moved onto the call stack, and this eventually logs 2. So now we have 5, 1, 3, 4, 2.
Bon, mais sérieusement, ça c'est quoi? Ça c'est juste bon. Ça veut dire, c'est juste pour le test, pour dire que bon, Q, microtax, ça pas directement dans le Q microtax, quelque chose comme ça. Ok, moi je vois. Ça peut être. Bon, j'ai plus besoin de ça. Non, elle a dit ça est directement résolu. Donc, quand c'est passé, on n'a plus besoin de passer ça ici parce que on n'a pas créé un promise. Si on crée un promise avant que ça devait créer un promise object qui devait faire tout ça. Mais le fait que c'est promise.resolve, ça part directement ici. Oui, 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 oui. Après, on fait un timeout. Oui, c'est là. Pendant que ça attend, des autres codes sont exécutés. Mais mon problème, c'est. Elle a juste pris ça comme un exemple pour dire que ça vient directement ici. Bon, moi, je pensais que c'était une fausse. Mais. Bon, ça, c'est juste un exemple. Mais je pense pas qu'on peut. Ok.
Then on the next line we have the then handler. The promise is already resolved, so in the background it does create that promise reaction, but the handler is immediately pushed to the microtask queue. Then we have set timeout, which is responsible for initiating the timer. So the callback and the delay get passed to the API, and in the background the browser starts some sort of timer. Then we have queue microtask. So the call is added to the call stack, and this queues that callback to the microtask queue. Then we have the synchronous console log 5, so this gets pushed to the call stack and logs 5. And in the meantime, the 10 milliseconds are up, so the callback from set timeout is pushed to the task queue, because this was a callback-based API, so task queue. Our script is done, the call stack is empty, so the event loop checks the microtask queue. And there we have the promise handler callback, and this eventually calls console log 1, so 1 is logged to the console. Then we have the queue microtask callback, and within this callback we call console log 3, so 3 is logged to the console. Then we call another queue microtask, and this queues another microtask with its callback to the microtask queue. However, the event loop has to ensure that the microtask queue is entirely empty before moving on to the task queue. So that callback is immediately moved onto the call stack again and logs 4. Now finally, the call stack is empty and the microtask queue is empty. So the first available task from the task queue is moved onto the call stack, and this eventually logs 2. So now we have 5, 1, 3, 4, 2. So let's just recap what we've covered so far. So JavaScript is single-threaded. It can only handle one task at a time. We can use web APIs to interact with the features leveraged by the browser, and some of these APIs allow us to initiate async tasks in the background. So the function call that initiates an async task like that is still added to the call stack, but this is just to hand it off to the browser. The actual async task is handled in the background, so it does not block the call stack. The task queue is used by callback-based web APIs to enqueue the callback once the asynchronous task has completed. Then we have the microtask queue. Which is only used by promise handlers, the async function bodies after await, the queue microtask queue callbacks, and the new mutation observer callbacks. This queue has priority over the task queue, and the event loop ensures that this queue is entirely empty before moving on to the task queue. And after handling each task from the task queue, the event loop again checks the microtask queue to ensure that nothing has been added in the meantime. You often come across asynchronous JavaScript, and if you aren't entirely sure why things execute a certain way, it might just be very discouraging. But I hope that my explanation for the task queue and the microtask queue and the event loop kind of helped you understand why certain parts of our code execute at a certain time. Of course, as always, if you have any specific questions, feel free to...
Bon, il me faut un exemple, un exemple. Je pense que je vais faire des exercices ici du code par bon, je vais essayer de callback section. Time out callback to condition. Bon, on voilà dit, puis on fait l'exercice. Attends, est-ce que j'aurai le temps? Non. Bon, mais c'est seulement... Oh, c'est pas ça que je cherche. Attends, ça c'est un nouveau thème pour moi ou pas? Ok, dégueule. Bon, je pense que je vais prendre un exemple. Ça, je vais garder ça pour après. Je vais essayer de faire un exemple ici. Ok, venons ici. On dit delete callback function. Ici. Bon, là, on va delete, on dit write a reversive function that takes a callback and invoke it after a delay of 2 seconds. Bon, function. Qu'est-ce que je peux écrire? Check. Je crée juste un truc au hasard et maintenant, qu'est-ce que la fonction s'y fait? Ça nous return un callback function. Ça nous return une autre fonction en fait et la fonction va faire quoi? Bon, je peux même mettre ça juste un oh, delay callback function. Là, je fais set timeout. Je fais un set timeout. Et le set timeout va prendre une fonction. Et maintenant, la fonction va faire quelque chose. Cancel lock. Ici, je peux même print la variable. Alors, je vais ici, je fais 15 time. Message. Message was hello world. Maintenant, ici, je print message. Après, combien c'est quand? Attendez. C'est ça, la fonction et le temps. Après 5 secondes. Là, je regarde ici, je viens, j'appelle ma fonction ici. Bon, est-ce que c'est ça? Ok. Ok, bon, on ne peut pas savoir si ça a vraiment delay. Donc, ce qu'on va faire, c'est lorsqu'on appelle la fonction, on va faire une console.log dédié waiting, quelque chose comme ça. Et maintenant, pour vraiment savoir si ça a vraiment delay, on va exécuter et ça fait waiting d'abord. Après 5 secondes et ça display hello world. Ouais, je pense que c'est ça. Je pense que c'est ça la solution de delay callback function. Bon, ils ont dit 2 secondes. Si je vais ici, je mets ça en-dessous. Ouais, c'est toujours pareil. Bon, comment on vérifie? Ça fera une fonction, ça retourne. Voici mon callback function ici. Ça nous retourne une fonction. Bon, voici le callback function là. Et le callback function est delay de 2 secondes. Ouais, je pense que c'est ça. Et on voit ce que les gens nous proposent. Bon, on dit what on rate your function evoke after delay callback set display message. En fait, le callback function, c'est ils ont pris ça comme un paramètre, mais moi j'ai directement mis ça dans ma fonction. Donc ça veut dire que je pourrais venir ici et je faire genre je faire quelque chose comme cons. Je fais genre callback function, je vais faire ici display message. Mon display message fait quoi? Ça nous fait un console.log. Je le mets ici. C'est quoi ça? Ok, bon. Attends, je déclare moi. Ok. Sauvegarde. Et puis maintenant, je viens prendre la fonction ci. Et je passe ça ici. Alors, ça. Callback qui est là. Et je prends mon callback. Je mets ça ici. Et puis maintenant, en display, si on va prendre un paramètre, le paramètre est quoi? Ça. Alors, ouais, je pense. Parce que mon callback function, c'est un paramètre. Le paramètre, si. R. Pourquoi je me... Est-ce que je dois me return ou bien je peux directement appeler ça comme ça? Ok, c'est ça. Pensez que ça est appelé ici. Et pour que ça display, ça va d'abord attendre 2 secondes. Donc, c'est que ça sera affiché avant ça. Ok, on voit le résultat. Là, ça fait waiting. Bon, c'est quasiment la même chose, mais c'est juste la différence de syntaxe. Que de mettre que d'appeler ta fonction directement, tu peux créer une fonction à l'extérieur. Oui, mais attendez, j'ai oublié. Comment j'ai oublié comment créer un poste user? Si je vais créer une fonction, c'est ça. C'est quoi ça? Ok, moi je pensais que j'avais oublié, je savais que je suis pas obligé. Oh, c'est correct. Je pensais que j'avais oublié. Mais c'est bon. Ok, qu'est-ce qu'il faut faire? Bon, callback to promise convection. Write a function program that converts a callback based function to a promise based function. Bon, attendez. Je comprends pas. Bon, là, je vais juste commenter ça. Ok, callback to promise. Bon, on sait d'abord que voici à quoi un callback ressemble. Et maintenant, on veut convertir ça en promise. Bon, voici ma fonction ici. Et je veux convertir ma fonction ici à une promise. Comment je commence? Je crée d'abord une promise. Ok, bon, voyons voir. New promise, ça prend un result. Bon, ok. La fonction, on va faire function. Conversion. Promise. Bon. Conversion sur promise, c'est-à-dire ça va prendre une fonction. Ça va prendre un callback function. Bon, callback function, c'est ça. On dit callback to promise. Conversion to promise, ça prend la fonction callback. Et maintenant, bon, avant toute chose, je vais faire un truc. Je vais d'abord créer un promise en fait. Je vais créer une fonction qui pour voir comment je vais. Ok. Pour créer un promise, je fais un return de new promise. Ça prend une fonction qui a resolve, puis reject. C'est bien ça. Et ça va nous faire ça comme ça. Bon, maintenant, qu'est-ce que ça fait? Les conditions. Bon, on va créer. Et si je peux créer les conditions, genre, je fais juste un. Bon, non, ça veut dire que if is valid. Bon. Je pense que j'ai mal compris. Ça va faire. Bon, ouais, c'est ça. Bon, là, je vais d'abord commenter ça. Je pense on dit callback to promise. Est-ce que le paramètre serait déjà un callback function que ça va nous retourner un promise, quelque chose comme ça? Mais bon, là, je crée un promise, display promise, c'est-à-dire ça crée un promise, ça vérifie si le nom, si c'est invalide, bon, ça va faire ça. Else, ça va reject. Ça va reject, mais c'est une value user. Ok, pour rendre ça un peu consistant, je vais créer, je sais de comprendre, donc, et je vais faire un password equal to, le password c'est ça. Le password c'est maintenant, mais ce que je dois faire, ça c'est le username, ça c'est le password. Maintenant, je dois faire un truc, genre je vais faire cons enter password. Oui, mais enter password serait quoi? Ça serait un prompt. Oh, c'est quoi? Je sais même plus. Input. Est-ce que c'est input? Non. Comment on demande à l'utilisateur d'entrer des informations dans Java? C'est plus chaud. Bon, je suis habitué. Ok. On va juste faire un truc. Vite faire. Je fais un truc vite fait. Index.html là. HTML. Bon, là, je vais demander à l'utilisateur. Mais sérieusement, c'est quoi? Là, je vais demander à l'utilisateur d'entrer un mot de passe. Si le mot de passe est death. Maintenant, c'est juste un simple truc. Bon, qu'est-ce que je vais faire? H1, login. Et maintenant, qu'est-ce qui doit se passer? Il y a un input qu'on crée, un input type text. Et je fais un dire de password. Ouais, c'est juste ça. Bon, c'est ça, je vais juste essayer de comprendre ça. Bon, là, enter password, ça serait quoi? Ça serait document.get element by ID. Qui est ça? Et maintenant, login. Qu'est-ce que je fais? Bon, il faut que je finisse vite ça avant de sortir. Login button. Ça serait ça. Maintenant, enter passe. Bon, ça serait ça. Le mot de passe de la personne est ça. Imaginons, on a fait un fetch, on a récupéré le mot de passe et tout. Bon, ouais, c'est ça. Après, ça fait la vérification. Is valid. Alors, on n'a plus besoin de is valid. On a juste besoin de le mot de passe. Si la personne a entré le mot de passe avec si si le password est égal au enter password, donc ça veut dire que ici enter password dot value. Qu'est-ce que je me fais? Je vais me venir ici mettre dot value depuis dot value ici, comme ça je viens ici est égal au password. Si c'est égal au password, on fait ça va faire un résolve, de message ici, et le message il serait une alerte. Le message ici ça serait une alerte, ou bien ça va faire ça. Maintenant c'est ça. Maintenant, qu'est-ce qu'il faut faire? Il faut mettre le bouton login add event listener. C'est lorsque le bouton est cliqué que le premier c'est display. Si on ne clique pas le bouton, ça ne fait rien. Là, ça va prendre un callback function. Puis on fait ça. Bon, je vais d'abord exécuter un peu mon code. Tu vois, si je peux dire open a live server. Bon, là c'est ça. Attends, je désactive mon extension. Ok, on mettra ça comme ça. Ok. Maintenant, ça veut dire que si je fais ça. Bon, ça veut dire que lorsque la personne va cliquer sur le bouton, on doit vérifier si le mot de passe est égal au machin. Donc, ça veut dire que ça va faire. Ça va faire un display function dot den. Den, c'est la condition si c'est vrai. On va faire result. Bon, pas result. Message. Message. Qu'est-ce que ça va faire? Ça va faire alerte du message. Bon, on peut. Oui, on va faire alerte du message. Là, si c'est ça, je suis perdu. Den. Maintenant, dot catch. Bon, on va faire alerte message. Bon. Ok. Le mot de passe c'est bon, chez ça, qu'est-ce qui se passe? Ça fait message invalid user. Ouais, c'est ça. Maintenant, c'est genre 1, 2, 3, 4. Ça fait message. Attendez voir. 1, 2, 3. Merde, c'est la même chose. Ok. Résolve 6 ça est égal à ça. Enter user. Le problème vient sur la vérification. Value, value, value. Je vais un peu essayer un truc. Je pense que mon type n'est pas la même chose. Ok. On va venir ici. Mettre un et submit. Ça veut dire que ça n'est jamais appelé. Ça veut dire que ça n'est jamais vrai. Enter password est égal. Non mais c'est bon. Pourquoi ça n'est 1, 2, 3, 4. Return promise resolve. Mais c'est chez nous. Disons, j'entre. 1, 2, 3, 4. Je fais save. Ok. Ouais, parce que 1, 2, 3, 4. Mais pourquoi ça ne fait pas? Ok, on va enlever ça. On va remettre notre valeur. Message invalid user. Bon. Ça ne va pas, c'est vite. Bon, désolé. Login set button. Lorsque c'est cliqué, bon, enter password est vide. Pourquoi enter password est vide? Une question que je me pose. Enter password. Ok. Bon, là j'entre le. Hmm, hmm. Ouais, c'est ça. Ouais, bon, là, je peux plus récupérer la valeur parce que c'est déjà dans une fonction. Quelle est la fonction? Ok, bon, ça y est que directement que c'est créé, on crée le premier. Oh, je crée des noms, juste comme ça. Parce que si je mets ça à l'extérieur, pourquoi ça ne fonctionne pas? Si je fais login, ça met invalid user. Ça y est que ma vérification tire ne mange pas. Bon, ça y est que si je mets ça, moi je vais mettre password ici. Ok, bon, donc si je mets 1, 2, 3, 4, je fais login. Ça fait hello, ça fait le message hello John. Ouais, c'est ça. Mais comment vérifier si une valeur est nulle? Ok, je vois. Et je connais. Que de directement passer. Attendez, que de directement passer la valeur ici. Je peux prendre le paramètre en fait. Et maintenant la valeur est passée. Je peux essayer ça et voir. Ça, je commente ceci. Je commente ceci. Et maintenant que de directement passer la valeur, je prends juste le paramètre parce que je prends vite le paramètre. Et je viens ici. Dot value. Et je viens là, je mets dot value. Puis je peux regarder si la valeur est vide. Quand ça doit être là. Ok. Enter password. Est-ce que ça va dot value? Ok. Ouais, je regarde. Bon, là je mets aucun truc. Oh, la valeur est vide, oui. Mais je veux que ça vérifie. Comment? Pourquoi ça ne vérifie pas? Not null, un truc bizarre. Ok, là j'entre le mot de passe, je vois. Centre. Ok, ça veut dire si je fais un constant du truc point value, ça va prendre la valeur initiale. Et la valeur initiale, c'est un truc vide. Donc, ça veut dire que je dois juste récupérer l'élément. Et c'est lorsque je fais ma vérification que je prends la valeur. Mais maintenant, je sais pas pourquoi ça. Mais dans les normes, ça doit fonctionner. So. Bon, là, je dois. Ça, c'est. Hi. Oh. What am I doing today? Like, I'm just trying to learn promises, something like that. Just trying to adapt with current situation, like and also the event loop. Okay, yeah, good. This is the code here. I'm just trying to apply promises inside my code. I just want to see how it works. But I'm having an error. Like I just no, yes, they create. I'm calling the display function inside the I'm calling the display function when the button is clicked. So when it's clicked, it's going to say something, but I don't understand why my value is empty. Like, I want that when the password dot value, I don't know if it's like that out while verifying if an input element is empty. I want this message to be display reject, like no password enter if this thing is empty. But when I'm logging in, they say invalid password, mean that yeah. Okay, like I've not reached that step. I was just trying to learn with what I've understood. What I've understood here. Maybe it's in the next chapter. Let me see if it's in there. Not. So you need a synchronous function. Oh. Okay, I think I need to. Well, yes, in here I should write something like, but the problem is that I don't know how to use it. You said something like this. The minute. Oh, yes, display the function. It is here. Yes, but the problem is that I've not yet reached that step. Maybe maybe when I'll be informed, I will understand. For the moment, what I learned, the person did not explain those terms. So I think I'll just in the next chapter. For sure, it's going to be in the next chapter because here I'm learning asynchronous code without using all these things. So I'm here. That's what I'm learning. Yes, like this is what I wrote. I know. Just like that with nothing else. Okay, let me see. Meaning that I don't know how to use it for the moment, so I'm just using like something like that for the moment. I'm just like learning without using this acronym. Maybe later on I'll just try to understand other things, but I think it's okay for me today. I'll just continue it later on, like tomorrow, because I'm following this course. This is the password. This is the password inside, like maybe inside the database. This is the password, and if the user, for the user to be logging, with yes, it's correct. Like I did all correct, but my problem is that I want that when the entered password dot value is null, it should display this message. There's what I want here, but instead of displaying my message, it's instead displaying invalid password, but meaning that this verification have passed. Is one. I thought that. Okay, I'll just try it and see. The same thing. Enter dot null, but it's supposed to be null. I don't know if it's null or what. But I think I will end here. I'm already. I have to go out. No, nothing. Wait, I want to do something. I want to verify the type. It is saying that it is a string. It is. Scroll up. Because here is going to take the parameter, and it's just that I'm already. I have to go out. I have to. Because this session has ended. Yes, I've entered. I've entered at the last moment here. Like, I've entered here. I'm taking the value. I want the value. It's going to take. It's empty. I think it's the same thing. Like, here. Save. It's some empty string. It's no, I want the value. The value is empty. It's still, it's still displaying an empty value. When I enter 1, 2, it's going to display 1, 2, 3. Yes, it's going to display the model past the value, but when the value is empty, I wonder if I don't know why. Okay, no password entered. Ah, yes, it's correct. If true, if false. Okay. Oh, this. Yes. Okay. Oh, it's okay for today. I'll see you next time. Thanks for the help. I've seen the error. I thought I'm going to verify if my value is null. Mean that, but it's still the same. Like if it's true, this, else this. Okay, it's correct. Mean that one I've no password enter. Okay. Oh, that's great. Thanks for your help. I think I'll end here for today.